Hello everyone, welcome to Rapid Syntax. So today we will be solving today's Leetcode contest question, and it is first question: check if bitwise or has trailing zeros. So it is a very simple question. It is of easy difficulty tag. So let's start the question first. You are given an array of positive integers nums. You have to check if it is possible to select two or more elements in the array such that bitwise or point out two or more elements. We have to select two or more elements such that bitwise or of the selected elements has at least one trailing zero. One trailing zero. So it is an also point to be noted. Two or more elements have to be we have to perform bitwise or on two or more elements to find out that they should have at least one trailing zero in its binary representation. So, for example, what is meant by trailing zero? Let's first understand it. For example, 101, which is the binary representation of 5, does not have any trailing zero, right? And 100 is the binary representation of 4, which has two trailing zeros. Trailing zeros means zeros present till the lastmost point position. From the lastmost position, we can say so the number of trailing zeros this is. And at the last most position, here is no zero present, so there's no trailing zero. So if there are trailing zeros, after performing bitwise OR operation on two or more elements, then we will be returning true, otherwise we will return false, right? So first understand how will let's see is do we need this more elements? Do we need to require check on two, three, four, or how many number of times, or for how many number of elements? I guess we do not need to check on more than two elements. The reason for that is if we have more than two elements, then it will be lesser chances that we'll be getting zero at that position. Suppose I have two numbers zero zero, right? Now the bitwise OR of these two numbers will itself be zero, right? This will be my result after performing bitwise OR on this number and this number, right? But if I'll be taking one more element, it may have one at this position or it may have zero at this position. So the probability of getting zero at this position will reduce. So we will be taking only two numbers in count and we'll checking for only two numbers, not more than that, to get the our answer, our required answer. So, um, first thing which we get to know is about that we do not need to take into account more than two elements. We'll be checking on only two elements. So, first we'll be finding bitwise OR of two elements, every possible pair of this array. So, bitwise OR. Now, after finding bitwise OR, we need to check if it has trailing zeros or not. So let's see how we'll be checking that it has a trailing zero or not. So suppose we have a number 100, which is a binary representation of 4, right? It is a binary representation of 4. So how will be checking it? A trailing zero means last most zero. If at least one trailing zero I have, then I can say I have a trailing zero, right? So for checking the bit present at the last index is 0 or 1, we can what we can do is we can perform bitwise AND operation with this number. If in this bitwise AND operation last bit is 0, or we can say complete number is 0, because all these bits will be 0, and we don't care that here it is 1 or 0. because in result we are always getting 0 at these indexes. But we take care about this index. If we get 1 at this position, then we have a trailing 1, not trailing 0. And if we have 0 at this index, at this position, so we have trailing 0, because this 0 and 1 gives 0. So we get to know that here trailing 0 is present. Similarly, in this case, it is a uh, binary representation of 5. When we perform bitwise AND operation of this number with this number, which is uh, how we'll be getting this number. Let's see. We'll be getting this number by one left shift 0, right? Because in this number, we are what is meant by one left shift 0? One left shift 0 means one left shift 0 means one is shifted 0 positions. So one is present at this position, and all other positions should be filled with zeros. So we get this number 001 using this technique, right? And when we perform bitwise AND operation of 001 with the 101, that is 5, we get 1 at last position, which shows that we do not have any trailing 0 in this number. So now it's very simple. Let's move to our question and start writing the code. So first of all, what we'll be doing is, and since its constraints are very less, we can solve it in n square, easily solve it in n square. Let's do it. Int n is equal to nums dot size. So first of all, we got to know about n. So int I is equal to 0 from I less than n, I plus plus for loop int j is equal to c. Let's take it I plus 1, j is less than n, j plus plus. So int num, or we can say our required value, is bitwise and of nums, oh, bitwise or, right? Bitwise or of nums I and nums j, if val and 1 left shift 0, if one val and 1 left shift 0 equal to 0, this we can say that if on performing bitwise AND operation on this number and this number, if we get 0, then we can return true, because it will be having trailing zeros, which we have seen just now, like this. If we have, after performing bitwise AND operation of number with 001, if we get 0, then the number is surely having trailing zeros. So it's pretty simple. Now, finally, we can return false. If in any case it is not returning true, then it must be returning false. So let's try for example test cases. True, true, false. What was it? True, true, false. It's correct. Let's try submitting it. Yeah, it's accepted. So let's take care of its time complexity. So in this case, time complexity is pretty simple to find out, because we are using simply two loops, which counts for n square. So its time complexity is simply n square. Thanks for watching the video. Good day. Bye bye.